Dear team, please give the co-host. Hello, am I audible? Dear host, please give the host co-host, please. Or sharing rights. Hello, hello, hello. Am I audible?
డయల్ చేసిన నంబర్పై ఇన్కమింగ్ సేవలు
రాకేష్ క్లాస్ చూసేది ఎవరు ఇవ్వాలా?
మన శ్రావణ్ అన్నాడు సార్.
వాడి నంబర్ లేదు. సరే వాడు హోస్ట్ ఇవ్వట్లేదు. ఎంతసేపటికి
బయటకు వచ్చిన ఉన్నా, నేను కూడా ఉన్నా. అదే ఈ ఆన్లైన్ ప్రోగ్రామ్ కోసం కానీ ఇప్పుడే బయటకు వచ్చిన.
ఎంతసేపటికి కో హోస్ట్ ఇవ్వట్లేదు, అది బాధ.
నేను ఒకసారి అడుగుతాను సార్. ఎవరికి ఏం పేరు?
నాదే కోటేశ్వరరావు.
మీరేనా? నేను అడుగుతాను సార్.
సరే. Yes. Hi all. Am I audible? Hello. Please reply. Someone. Am I audible? At least give the message. Am I audible or not? Please reply. Right. We continue my lesson. Hello. Right. I'm going to continue. Then, yesterday we are completed the classification of pericyclic reactions. Today we are going to discuss about stereochemistry of pericyclic reactions. Stereochemistry of pericyclic reactions. In which the first one, stereochemistry of electrocyclic reactions. Stereochemistry of electrocyclic reactions. Yes. Before going to the discussion of stereochemistry, I just want to just a minute. I want to increase the size. Right. Ah. Do you know the definition of the electrocyclic reaction? Yesterday we are discussing about the electrocyclic reaction definition. What is that? The formation of the sigma bond between the two terminal carbons. Suppose this is a pi system. Because there is one common butadiene, for example. Now each carbon, the terminal, and all the pi system, four carbons are two carbons. The hybrid is three carbon is S2. What does that mean? The carbon which is with three sp2 hybrid orbitals and one unhybridized p orbital. Each carbon with three sp2 hybrid orbitals and one unhybridized p orbital. Right. Now, whenever I am representing this molecule in the form of orbital, each carbon is existing with one unhybridized p orbital. These are the unhybridized p orbitals are existing on every carbon. Whenever these kind of molecules are undergoing electrocyclization, what's happening? There is a formation of bond between these two carbons. Bond formation happens between these two carbons. Now, how this bond is happened? How this bond is formed? For example, you are taking 1,3 butadiene. The students, are you there?
Yes, sir.
Hello. Hello, are you there?
Yes, sir.
Yeah, are you following or not? Because there is no sounds from your side. That's why I'm feeling only I am only talking here. Right. Then for the electrocyclization, these two terminal carbons are undergoing overlapping. These are their orbitals becomes come closer and overlapping. How this overlapping is takes place? This orbital is undergoing rotation. By undergoing this CC bond rotation, these two orbitals, terminal carbon unhybridized p orbitals, come together. They can be overlapped. Suppose at the intermediate level or in the transition state, these two orbitals are come to closer. They come closer and they become generate the pi bond at the end product. When they are overlapping, they produce the a new pi bond, sigma bond here, new sigma bond here. At the remaining two carbons, the unhybridized reactions, they will be overlap. They produce the new pi bond here. Now the final product is like this, right? For overlapping these orbitals, overlapping of these p orbitals, it may be undergoing rotation of this CC bond, undergoing the rotation of CC bond along the CC bond axis. CC bond axis. Because the CC bond axis, this is undergoing rotation. Rotation. This rotation may be, you can choose it. Either it may be clockwise rotation or it may be anti-clockwise rotation. Look at here. Either it is undergoing clockwise rotation or anti-clockwise. Therefore, for the formation of bond between these two carbon, that may be sigma bond, that sigma bond formation may take place by the rotation of the CC bonds. Two CC bonds are undergoing rotation. This CC bond rotation may happen either in the clockwise or in the anti-clockwise at each center. Therefore, we have four combinations. At the both the ends, suppose you treat it as a end 1 and end 2. At the terminal 1, terminal 2, or terminus 1, terminus 2. At the terminus 1, it is undergoing clockwise. Here, the second terminus is also clockwise. If it is the first terminus, it is clockwise. This is the first pattern. Okay, for the overlapping. The second, it is at the end is clockwise rotation. At the second end, it may be anti-clockwise. And the third turn, at the first end, it is undergoing anti-clockwise. At the second turn, it is the clockwise. At the fourth type, it is undergoing anti-clockwise first end, also anti-clockwise at the second end, second turn. Right? What observation you see that when you are observing these four kinds of uh, rotations at the two ends, right? At the first pattern, is both ends are doing clockwise and clockwise. That is, it is the same side rotation. Both are clockwise rotation. If you see that the second pattern, it is the first one is clockwise, is the anti, is the clockwise. This is the anti-clockwise. This is the rotation. Different rotation.
Sir, your
Is the
voice is breaking, sir.
clockwise rotation. Yeah, rotation. This is also different. Now here,
Sir,
this is
your
clockwise. This is the
voice is
clockwise.
breaking.
Both are anti-clockwise rotations. Yes, what? My voice
Voice
is breaking.
breaking, sir. Yes, sir.
Just yeah, yeah. Okay. Do one thing. I will make other arrangement. Okay. Just a bit. Yes. Now I am audible. Am I audible now?
Yes, sir.
Yes.
Right. Thank you. There. My screen is visible to you all?
Yes, sir.
Yes, sir.
Okay, okay. Thank you. Now, again, I'm repeating, just you are not listening well. Okay. If you take, this is the molecule is undergoing electrocyclization, right? For the electrocyclization at the two terminal orbitals need to be overlap. For the overlapping, this carbon-carbon bond and this carbon-carbon bond need to be rotate for coming closer of these two orbitals. For getting closer of these two orbitals, it is undergoing rotation at first terminal and at the second terminal. Then the rotation may be at the first terminal may be clockwise, at the second terminal is also clockwise. Both are clockwise rotation. Clockwise rotation. Therefore, this is known as same rotation. This same rotation is known as conrotatory electrocyclization. Conrotatory electrocyclization. Right. Both are undergoing same kind of rotation. Both are undergoing same kind of rotation. Now, if at the first end it is again clockwise rotation, at the second end you treat it as first pattern. In the second pattern, at the first terminal it is undergoing clockwise rotation. At the second terminal it is undergoing anti-clockwise rotation. It is anti-clockwise rotation. You see that both are different rotations. One is the clockwise rotation and second one is the anti-clockwise rotation. This is different rotation, opposite rotation. Different rotation. This rotation is known as disrotation. Disrotatory electrocyclization. Disrotatory electrocyclization. You come into third one. At the first end, it is the anti-clockwise. At the second end, it is clockwise. This is the anti-clockwise rotation. It is the clockwise rotation. That means this p orbital is undergoing clockwise. This bond is undergoing anti-clockwise rotation. This is also similar to the first one, the second one, different rotation. This is also known as disrotatory electrocyclization. Now coming to the fourth pattern. Both are anti-clockwise rotation. Both are same direction, they are undergoing rotation. Anti-clockwise rotation. This is also anti-clockwise rotation. Now this is also same kind of rotation. This is known as conrotatory electrocyclization. Therefore, based on this observation, Pericyclic reactions are showing two stereochemical modes. Electrocyclization reactions. Electrocyclization are showing two stereochemical modes. That is, first one is Kahn rotatory electrocyclization. This can also be represented as Kahn, C-O-N, capital, Kahn electrocyclizations. Kahn electrocyclizations. Second one, this rotatory electrocyclizations. It can be represented as DIS, capital, electrocyclization. This electrocyclization. Then coming to the examples, you can take the first step. As per the classification of electrocyclizations, 4n 5 electrons or 4n electrons involved, 4n electrons involved electrocyclization reactions. Four in electrons involved electrocyclic reactions. Now it shows the first stereochemical mode is Kahn electrocyclization. Kahn electrocyclization. What is the Kahn? What is the Kahn? The terminal orbitals are overlapped by the rotation of CC bond in the same direction at both the ends. The terminal orbitals are overlapped by the rotation of CC bond in the same direction at both the ends of the phi system. The phi system. Here the 4n electrons are 4n electrons electrocyclization. Right. Take this example. Same 1,3 butadiene derivative. But for our understanding, I am substituting it with at methyl groups at both the ends. If you see this, its name, give the number 1, 2, 3, 4, 5, 6. Then 2, 4 hexadiene. 2,4 hexadiene. Right. Now, whenever you are writing it in orbital structure, that is every carbon in the unsaturation is having one unhybridized p orbital. The 5 bond I am representing like this. This is unhybridized p orbital. Right. Now, across the CC bond axis, this is a CC bond axis. This is a CC bond axis. Across the axis, this is the C1 and C2, C3 and C4. Right. It is a C bond axis. Across the axis, it is undergoing at the first end, at the C1, it is undergoing clockwise rotation. At the C4, it is also on rotating clockwise. Some eraser is not working. Right, okay. It is clockwise rotation. At the both end, it is rotating clockwise rotation. Look at here, whenever it is undergoing clockwise rotation, look at here, it is undergoing clockwise rotation. Then at the middle of the complete rotation, you observe that there is no change at a C2 and C3, but you can observe that the orientation of orbitals at the partial orientation of the orbitals, both are undergoing clockwise rotation. They are moving like this. They are moving like this. Now this is known as Kahn rotation. This is one type. Right. Look at here, whenever it is rotating, look at here, this orbital is rotating clockwise. The CH3 group is outside, hydrogen is inside. During the rotation, the methyl group is moving up, hydrogen is moving down. Similarly, at the second carbon, it is also undergoing clockwise rotation. The methyl group is moving down, hydrogen is moving up. Then the attached bonds oriented like this. This is the CH3, this is the hydrogen. This is the hydrogen, this is the CH3. After complete overlapping, whatever the product we can get, this is the product. The sigma bond is established between these two carbons. Now this is the 5 bond. After complete formation of this sigma bond, the groups attached at the C1 and C4 in the starting material will be placed like this after the complete formation. Whenever we are representing complete structure, this is the methyl group above the plane, hydrogen here above the plane, hydrogen it is the beta bond, it is methyl group below the plane. Now look at here, these are trans to each other. The two methyl groups are trans to each other. When the rotation is at both the ends are clockwise. Suppose if it is anti-clockwise route, this is the first kind pattern. Now we are coming to the second kind. That is both the ends, at the both the ends, it is undergoing anti-clockwise rotation. Anti-clockwise rotation. You can take it as Khan 1 model, right? You can take other thing, Khan 2. Khan 2 means in the Khan 1, both the ends are rotating clockwise rotation. Khan 2, at both the ends, it is anti-clockwise rotation. At the C1 and C4, both the ends, it is undergoing anti-clockwise rotation. What's happening? You can check it. After partial rotation, you can observe it. At the partial rotation, the orientation of the partially rotated 5 bonds, you can observe like this, right? There is no change at C3 and C2, but at the same time, the inside, whenever it is rotating anti-clockwise at the C1 and C4, the attached substituents, the inside group is moving up, outside group is moving down. That is hydrogen is moving up, methyl group is moving down. Similarly, here at the C4, the methyl group is outside group that is moving up during the anti-clockwise rotation, and the inside group hydrogen is moving down. After formation of the product, after completion of the reaction, you can observe like this. These are the attached bonds, and this is the 5 bond between these two orbitals. Now, after complete movement, rotation and form the sigma bond between the C1 and C4, the orientation or the arrangement of the substituents at C1 and C4. You get it here. You get it. Two methyl groups are trans to each other. Here also the product is trans. If you observe that the product is trans product in both the case, the same product is obtained. That's why it is the pericyclic reactions are highly stereospecific. Due to the reason highly stereospecific. Okay, this is about the Kahn rotation, Kahn electrocyclization, the first mode of stereochemistry of pericyclic reaction. Right. Now coming to diselectrocyclization. So same 4n electrons involve electrocyclization with the diselectrocyclizations. The second mode. The second stereochemical mode is disrotatory or diselectrocyclization. Do you have any doubts? Please. You can interact, no problem. You can interrupt me, no problem. If you have any doubts, you can interrupt me during the class. I will wait there and answer your question and move forward. Any doubts?
No, sir.
Are you following?
Yes, sir.
Right. This electrocyclization. You take the same molecule. Here I am going to take the same molecule. These are the p orbitals. When you take that. This is the CC bond axis. This is the CC bond axis again at the between the C4 and C3. It is the CC bond axis between the C1 and C2. Across the axis, if you follow that with respect to that axis, at the it is the diselectrocyclization, means when you compare the rotation at both the ends, opposite rotation maybe takes place. Opposite rotation means at one end it may be clockwise, at the second end it may be anti-clockwise or vice versa. That is different or opposite rotation of the CC bond for overlapping the terminal carbon orbitals to form a sigma bond to get the electrocyclization reaction. First pattern, if you see that the first pattern, it is here the clockwise. At the second end, it is the anti-clockwise, opposite rotations. Opposite rotations. Now it is treated as this one. It is treated as this one. Then what's happening? Whenever it is rotation, same substitutions you can carry from the previous example. Right. Then after rotation of this is undergoing clockwise rotation. That is, movement is like this. The outside group is moving up, the inside group is moving down. Similarly, at the second end, it is the anti-clockwise rotation. That means that during the anti-clockwise, this is the rotation pattern is like this. Okay, the outside group is moving up, the inside group is moving down. Clear? Then there is a 5 bond between these two orbitals C2, C3, and after completion of the rotation, what's happening? The inside group is moving down, therefore hydrogen is here. The outside group at C1 is moving up, is a CH3, and at second end at C4, during anti-clockwise rotation, the outside group is moving up, the inside group is moving down. Look at here, the product is cis product. Product is cis product. Now this one is this at first carbon is clockwise, at the second carbon is anti-clockwise. Similarly, you can take next pattern, the second one. At the first carbon is anti-clockwise, and second terminal is undergoing clockwise rotation. That means the rotation is like this. This can be shown like this. This two rotation. What's happening? Look at here. At the first terminal, it is anti-clockwise rotation. I am removing the previous ones. Right. It is undergoing anti-clockwise rotation. That is, rotation is like this. During that, it is undergoing the changes like that. The outside group is moving. The outside group moving down. The hydrogen inside that is moving up. At the second terminal, it is the clockwise. Now, whenever it is undergoing clockwise rotation, the rotation is like this. Clockwise rotation. During the clockwise rotation, the outside group is moving down, the inside group is moving up. Then what is the product here? You carry the same changes to the molecule. Instead of writing, I'm writing orbital structure, directly I'm writing the compound. This is a newly formed sigma bond between the C1 and C4. At the first termini, it is undergoing the anti-clockwise rotation. Therefore, inside group is moving up. Therefore, hydrogen is here. Outside group is moving down. Therefore, methyl is occupied here. And at the C4 termini, it is undergoing clockwise rotation. Therefore, the outside group is moving down, the inside group is moving up. Again, the product is cis product. If you look into here, when you compare the Kahn rotation and the same molecule, if it follows the Kahn electrocyclization stereochemistry, the product is trans product. Follows the Kahn electrocyclization stereochemistry, right? It gives the trans product. Or if it is following this electrocyclization stereochemistry, that gives the cis product. If you see that, you can clearly understand that the stereochemistry is differentiated the products. Product formation is differentiated. Therefore, electrocyclization reactions are showing two stereochemical modes. One is Kahn electrocyclization, the second one is dis-electrocyclization. The products which are obtained in the Kahn electrocyclations are different from the dis-electrocyclization, or the stereochemistry of the products obtained in the Kahn electrocyclization are different from the products obtained in the dis-electrocyclization reaction. And other example, if you see that here we have seen that 4 and 5 electrons or 4 n electrons involved electrocyclization reaction. For example, if I am going to observe the changes in the 4n plus 2 electrons involved in the electrocyclization reaction. The second 4n 5 plus 2 electrons involved electrocyclic reactions. Electrocyclic reactions. Then here I am going to take the product is starting material is cyclohexatriene derivative. Cyclohexatriene derivative. For your understanding purpose, I am taking the same substitutions. Methyl group here, hydrogen is here, hydrogen is here, and the methyl group is here. So instead, I am taking the some larger size. I will make it into large size structure. Okay. Right. Hydrogen CH3, hydrogen CH3. Right. Whenever you are showing this one in the orbital representation form, right here the C2, C1, C3, C4, C5, C6, and attached substitutions. Here the hydrogen and the methyl group. The drawing of these orbitals are very important to need to understand for understanding the further concepts in the pericyclic reactions. Okay. Now, first you can construct the Kahn electrocyclization this side. Kahn electrocyclization. Kahn electrocyclizations. Con 1. In the con 1, at the first terminate is the clockwise, and the second terminate is also clockwise. At the both the ends, it is undergoing clockwise. For example, here, this one is the clockwise. Right. Clockwise means the rotation is like this. And here also, it is also clockwise rotation. During this rotation, what's happening? The outside group is moving up. Inside group is moving down. Here also the inside group is moving up, outside group is moving down. Then what's happening? What we are getting here? After the overlapping, the remaining 4 produces the 2,5 bonds. The substitutions. The substitution is one is here and second one is and like this. Look at here. During the clockwise rotation, the methyl group at C1 is moving up. And the inside group hydrogen is moving down. Correct? And at the C6, on anti-clockwise rotation, the inside group is moving up. The outside group is moving down. Then to write the molecule, CH3, hydrogen, CH3, hydrogen. Look at here. These two methyl groups are opposite to each other. Therefore, this is the trans product. This is the trans product. Then, con 2. You can take the second way. Con 2. At the two ends are anti-clockwise rotation. The two ends, it is anti-clockwise rotation. What's happening? Look at here. I'm removing previous illustrations. I may take the fresh one also, no problem. Okay. Is the images are visible to you? Are you following?
Yes, sir.
Okay. Is it the illustration is clear to you?
Yes, sir.
Right. Thank you. Now, con rotation at the con 2 at the both the ends anti-clockwise. At this first end anti-clockwise, at the second end is also anti-clockwise. Whenever it is undergoing anti-clockwise rotation, what's happening? The movement of groups are like that. As whenever it is undergoing anti-clockwise, the outside group is moving down, the inside group is moving up. Right? The inside group is moving up, outside group is moving down at a C1. At the C6, it is also anti-clockwise. Therefore, the rotation is like this. The outside group is moving up, the inside group is moving down. Right? Then what is the product here? Simply imagine it. It requires the more imagination. It requires the imagination only. Please imagine that. How it is rotating. During the rotation, what the movement taken by the attached groups. Then after formation of sigma bond between the C4 and C6 and C1, the attached substituents at the C1 and C6, right? It is at anti-clockwise. Therefore, the outside group is moving down. The methyl group is occupying this position, and inside group is moving up. At the C6, it is also anti-clockwise. Therefore, outside group is moving up. The inside group is moving down. Then look at here. When we convert into a complete structure of the compound. Hydrogen, CH3, hydrogen, and a CH3. Both methyl groups are trans to each other. In both the stereochemistry, the products are trans products are obtained. Both the Con 1 and Con 2 both are giving trans product. Next. We can take same example for different electrocyclic, rotatory electrocyclic reactions. We can take the same molecule. What is this? This means at the both ends, opposite orientation is or opposite direction of rotation is takes place. Right? You can take this one. At first carbon, at first carbon it is rotating it is rotating clockwise. At the C6 carbon it is rotating anti-clockwise. First it is rotating clockwise. C6 it is rotating. Please zoom user. Please mute yourself, please. Hello. Right, thank you. Yeah, right. It's C1, it is rotating clockwise rotation. It is undergoing clockwise rotation. At the C6, it is rotating anti-clockwise rotation. For the clockwise rotation at C1, what's happening? The rotation orientation is like this. The rotation orientation is like this. Therefore, during the rotation, the outside group of methyl group is moving up. The inside group is moving down. At the C6, it is undergoing the anti-clockwise rotation. The outside group methyl group is moving up. The inside group hydrogen is moving down. Then what is the product? After overlapping, we can see that right. The bonds at C1 and C6. The methyl group is moving up. The hydrogen is moving down. Next, during anti-clockwise rotation, the methyl group is moving up and the hydrogen is moving down. Therefore, the product is CH3, hydrogen, hydrogen. Then the product is cis product. Similarly, next kind of orientation, the possible orientation is this 2. At the first carbon is anti-clockwise. At the 6th carbon is clockwise. Anti-clockwise and clockwise. Then what's happening? The product Look at here. At the first carbon, it is rotating anti-clockwise. Therefore, the rotation orientation is anti-clockwise. During the rotation, the hydrogen is moving down, up. Inside group, hydrogen is moving up. Outside group, methyl group is moving down. Therefore, hydrogen is occupying this position. Methyl group is occupying this position. Here, at the 6, it is the clockwise orientation. Clockwise orientation means the rotation is inside group is moving up, outside group is moving down. Therefore, hydrogen is moving up, the methyl group is moving down. That means opposite orientation of rotation. Opposite orientation of rotation. Clockwise, anti-clockwise, or anti-clockwise, clockwise, vice versa. Then the resulted product is hydrogen, hydrogen, CH3, and CH3. Then what is the product? Here the cis. And the dis rotation gives the cis product. Con rotation gives the trans product. But the stereochemistry depends on the substrate what you have taken. Okay. These are the two stereochemical modes of electrocyclization reaction or electrocyclic reaction. What is one is the con rotatory electrocyclization. The second one is the disrotatory electrocyclization. For your practice, I am giving the example. For your practice, the hydrogen and methyl, hydrogen and methyl. Please predict the products. Dis electrocyclization and con electrocyclization. What are the products? A and B. Complete the reaction and post me in the WhatsApp group. This is your work. And another example. This electrocyclization, con electrocyclization, and X and Y. Complete the reaction. Post me the results in our WhatsApp group. And this is about the 4 electrons electrocyclization. And take the 6, 4 and 5 plus 2 electrons involved in electrocyclizations. CH3, hydrogen, CH3, hydrogen. Take these examples. Con electrocyclization. You can take this. Complete your reaction on a white paper and send it in WhatsApp group. Right. Then coming to the next pericyclic reaction.
Sir, once show me first.
Yeah. Copy it. I'll give you the time. 2 minutes time, no problem.
Okay, sir.
Okay, are you finished?
Yes, sir.
Right. Can I move forward? I will extend the class up to 1:45 because we have taken late joining. That's
Okay,
why
sir.
I'm
Okay,
extending the
sir.
class to 1:45 or 1:50. Meanwhile, you had lunch along with the class, no problem. Okay. Next, stereochemistry of cycloaddition reactions. Stereochemistry of cycloaddition reactions. The second one. Stereochemistry of cycloaddition reactions. Right. Before understanding the stereochemistry, first you need to understand the how these five systems. What is the definition of cycloaddition? What is the definition of cycloaddition? A conjugate addition of two or more five systems to produce the adduct is known as cycloaddition reaction. For example, you take the two olefins are undergoing addition that leads to produce a cyclic product, that is an adduct, cyclic adduct, or its reverse. Here in this reaction, two 5-electron system and two 5-electron system both are undergoing in a conjugate addition that leads to produce an adduct, or reverse is it is dissociated to two 5 molecules. That is a cycloaddition, cycloreversion. Right. For example, you can take the orbital structures of 5 systems. These two 5 systems are having two carbons. Each carbon is sp2 hybridized. Therefore, each carbon is existing with one unhybridized p orbital. These unhybridized p orbitals is overlapping with the orbitals of carbon or unhybridized p orbital of carbon of other 5 system. Therefore, these two orbitals may undergoing the overlapping to produce the sigma bond. These two orbitals are undergoing overlapping to produce the sigma bond. This overlapping is of different kinds. That means the involving lobe, based on the lobe which is involving the overlap, we can classify the cycloaddition reaction into 4 types. For example, first you need to understand that these two are undergoing interaction to produce the sigma bond. These two orbitals are undergoing interaction to produce the sigma bond. The product is like that. Suppose these are the interaction we can show. I just showing very rough diagrams only. These are the interaction, bonding interactions that leads to produce the product is like this. Okay, this is a cyclic product, right? This interaction, look at here. If you consider that this one is the first 5 system, this is the first 5 system. In the first 5 system, 2 lobes are participating in the overlapping with the 2 lobes of the second 5 system. Now, when you look into the 2 orbitals, we have 4 lobes, each have 2 lobes. Therefore, these 2 lobes, same side lobe may be participating in the overlapping. There is opposite lobes may be participating in the overlapping, or the above 2 lobes may be participating in the overlapping. 4 possibilities are there. First, based on this observation, you take one phi system. You take one phi system. This one first phi system is undergoing overlapping with the second phi system by interacting with the two unhybridized p orbitals of both. That interaction is involving the lobes may be on the same side. That means that these two lobes are participating in the overlapping with the second phi system. These two lobes are on same side. These two lobes are on the same side. Now, this kind of interaction with respect to that particular phi system is known as suprafacial interactions. Suprafacial interactions. What we call it as suprafacial interactions, or this is the addition reaction. We call it as supra-addition reaction. Supra-addition. This is the first kind. When we come into the same phi system, the same phi system is interacting with the other phi system with the overlapping of unhybridized p orbitals. At the first phi system, the carbon 1, the lobe is the lobe which is undergoing the overlapping with the second phi system carbon 1 involving this lobe. At the second interaction, instead of this lobe may be interacted. This lobe may be interacted. For this lobe interaction, this requires the CC bond rotation. CC bond rotation. First of all, you understand that these opposite lobes may be involved in the overlapping. This kind of interactions are known as anterofacial interactions or antra-addition. A-N-T-A-R-E. Antra-addition. In the cycloaddition reaction, 2 or more phi systems may be participated. 2 or more phi systems are participated in the addition reactions. Whenever you are classifying the cycloaddition reactions, first you need to observe that what lobes are involving in the cycloaddition with respect to that particular phi system. By combining all the phi systems orientation and spatial interactions, we can decide the stereochemistry. Now, you can understand that with respect to the first one particular phi system, if the both lobes are interacting with the second phi system are on the same side, that is known as suprafacial. If the interacting lobes with respect to that particular phi system is on opposite side, this is opposite side. Opposite side is known as anterofacial interaction. Now coming to the comparison with the two phi systems. This is the one phi system which is involving the cycloaddition. This is the second phi system which is involving the cycloaddition. It is the first phi system with the 2 phi electrons. It is the second phi system with the 2 phi electrons. In the first phi system, these two lobes are participating in the interaction. That means the interaction like this. This lobe is interacting with the second phi systems, the carbon 1 lobe. And this lobe is interacting with this one. Now, you close it. You just close it. You hide it. You hide it, second phi system. Observe the first phi system. In the first phi system, it is already involved the interactions with the second phi system. Observe it whether the two lobes are same side or opposite side. What is your observation? The two lobes are
Same sides.
same side. Therefore, with respect to that particular phi system, particular first phi system, it is supra-addition. It is undergoing Supra-addition. Right. Next. Okay. Now you can hide the first phi system now. You can hide the first phi system. And observe the second one. Observe the second phi system. Whether these two lobes are opposite or same side. Which these
Same
two are
side.
involving in the interactions. Therefore, this is also supra. Right? Then coming to both, we compare it.
Opposite sides.
No, just one. Now, with respect to the first phi system, both lobes are interacting lobes are on the same side. Therefore, it is supra. Right? With respect to the second phi system, interacting lobes are on the same side. This is also supra. Now, the first stereochemical mode of cycloaddition reaction is supra-supra addition. Supra-supra addition. When the electrocyclization reaction is involving two phi systems. Those two phi systems with respect to the first phi system is supra addition. With respect to the second phi system is also supra addition. That addition is known as supra-supra addition. For example, here the two electrons are involved in the first phi system. Two electron system of the phi system is involved in the cycloaddition. Therefore, with respect to the first phi system with the two electrons, it is undergoing supra addition. Plus, with respect to the second phi system, phi with the two electrons, it is also undergoing supra addition. Phi to S plus phi to S cycloaddition. The first stereochemical mode of the 4n electrons involved cycloaddition reaction is phi to S plus phi to S or supra-supra addition. First stereochemical mode. Now coming to the second one. Second mode. This is the first kind itself. Right? Again, you take the this is the first phi system. This is the first phi system with 2 phi electrons. This is the second phi system with 2 phi electrons. You make it one interaction becomes standard. And with respect to the first phi system, both are supra. Look at it. You hide the second phi system. Just observe the first phi system. It is involving the interaction with the second phi system. The first phi system is involving in the interactions with the second phi system. The interacting lobes are on the same side or opposite side. Interacting lobes are same side or opposite side. Same side. Therefore, with respect to the first phi system, it is supra. Right. Now you can hide the first phi system now. With respect to the second phi system, these are already involved in the interaction with the first phi system. The interacting lobes are here. One lobe is interacting here, and the second lobe is interacting here. Both the lobes are on
Different.
opposite side. Therefore,
Opposite.
this is antra. Now the second stereochemical mode is supra-antra. Supra-antra. Then it can be shown like this. Phi to S. Phi system with the 2 electrons undergoing supra addition plus second phi system with the 2 phi electrons and antra. small a. Right? Next, the third one. Right? You make it the one interaction is standard interaction, and the interaction is like this. You hide the second phi system, compare the lobes which are involved in interactions on the first phi system. Both the lobes are
Opposite.
opposite. Therefore, this is andra. These two lobes. Now hide the first phi system. Observe in the second phi system. Right. Both the lobes are on same side. Therefore, this is same side. I am expecting your reply. Supra. Therefore, the third stereochemical mode is andra-supra. Andra-supra. Suppose if the phi systems are with the 2 electrons, phi to A plus phi to S. Next, fourth one. To make it, this is the standard interaction, and the second interaction, it may leads to different. Now look in here, hide the first one, second one. Compare the overlapping lobes. These lobes, this lobe and this lobe. These two lobes are participating in the interaction with the second phi system. How these two lobes are located? In the first phi system, how these two lobes are located?
Opposite.
Therefore, this is andra. Now coming to here, in the second phi system, this lobe and this lobe is involved in the interaction. Then what is the status of existence of the? Yes, this is also opposite. Therefore, this is andra. Now the fourth stereochemical mode is andra stereochemical mode. That is phi to A plus phi to A. Based on this observation, cycloaddition reactions are showing four stereochemical modes. Four stereochemical modes. One is supra-supra mode, and the second one is supra-andra mode, and third one is andra-supra mode. And fourth one, andra mode. That means any kind of cycloaddition reaction, it can establish or the probability to produce or probability to show the four stereochemical modes. One is supra-supra, and second one is supra-andra, and third one is andra-supra, and fourth one is andra-andra. These four kinds of stereochemical modes are shown by the cycloaddition reactions. Right. Now, I'm going to show some examples. Yes. First, you take the cycle 1-butene. 1-butene is undergoing cycloaddition. This is the 1-butene, especially 1-butene cis-butene. phi2 plus phi2 cycloaddition of cis1 butene. Cis2 butene, sorry. Cis2 butene. Look at it. We are taking cis2 butene. H, CH3, CH3. And two molecules of cis2 butene is undergoing cycloaddition. Right. Now it leads to produce now the products, expected products. We have different stereochemistry may be observed, but in general, I am writing these products. All cis products, all trans products, cis trans product. That is depends on the stereochemistry which is going to be adapted. Right. It can participate. It can be participate in 4 stereochemical modes. One is supra mode, phi to S plus phi to S. That is supra stereo cycloaddition, or you can also write like this: supra cycloaddition, and phi to S plus phi to A cycloaddition. That is supra andra cycloaddition, and phi to A plus phi to S cycloaddition, and phi to A plus phi to A cycloaddition. These 4 stereochemical modes are shown by this reaction. This is andra cycloaddition, and this is andra suprani. Sometimes the eraser may be not working. Just okay, leave it. The below one is the cycle addition. This is not antra, this is supra. So supra cycle addition, antra cycle addition. Okay. Do one thing after after spectroscopy class at 6 o'clock, I think. You remind me, I will take another class continuously. Okay, if you are willing to attend, I will take another class after 6, after the spectroscopy class. Because it is it involves the lengthy explanations. It requires the more elaboration. Okay. Now you can take leave, join at 6 o'clock for the same organic class. But the remaining 2 classes are as it is. At 2 o'clock, physical chemistry class is there. At I think 3:30, spectroscopy class is there. Spectroscopy class may be end at 5 a.m. 5 p.m. You remind me 5 p.m. or 5:10 at 5:10 p.m. I will take the class. Okay. In continuation to this one. Okay.
Thank you, sir. Sir, notes share.
Yeah, the same thing will be shared to you after completion of this class. Okay.
Oh, okay, sir. Okay. Thank
Right.
you.
Right.